Let's have a look at question 2 in this video. So the company decides to give the employees a choice between individual production and production in a team. Okay, so if they produce in a team, they receive the same base salary A and a bonus based on team production, which is going to be 1/2 times the bonus per unit of output. Now, if they do work as a team, then that will be the production of the team, where K is greater than or equal to 1. Now the question is, if K is greater than 1, then the team production entails synergy effects. Now what's the idea of the synergy effects? Is that if they work together, then by the fact that they cooperate, they can produce more than by working separately. So let's see how that will hold. We're interested to know under which condition the total production, total quantity produced of the team is going to be greater than the total quantity produced when they work as individuals. Now, if we look at the beginning of the question over here, it's given to us that every employee chooses effort independently. So independently is the key word. And we found out what the optimal effort is. When they choose independently, they maximize their own utility. So that's going to be the level of effort, B times V divided by theta. Now with that in mind, we'll use this effort level to find out the total quantity produced as a team. So the total quantity produced as a team, let's write it over here below. Total quantity produced as a team, that's equal to K times V multiplied with the effort of the first individual plus the effort of the second guy. Now, what was the effort? The effort, once again, let's just take it from here, B times V divided by theta. So we will substitute B times V divided by theta for both guys. We'll have the following. We'll have K multiplied with V multiplied with B times V divided by theta plus B times V divided by theta. Now, if we open the brackets over here, what do we have? What do we get? We'll have the following. We will keep the K, and then V we will multiply with every term. We'll multiply with the first term so that we get B times V to the power of 2 divided by theta, plus we multiply it with the second term and we get B times V squared divided by theta. So that will be the total quantity produced as a team. Now, what will be the total quantity produced individually? So if they work separately, two people work separately. So total quantity produced individually, well, that's just going to be the production of the first person, production of the first, plus production of the second. And we already found out what the production is. From here, we found out that this is the production of one individual, B times V squared divided by theta. So let's write that down. We will have B times V squared divided by theta, B times V squared divided by theta, plus B times V squared divided by theta. Now with this in mind, let me just zoom out to get some more space. With this in mind, how can we have this synergy effects? Well, we said we will have it when the total quantity produced as a team is greater than the total quantity produced individually. So let's see when that holds true. Well, that will hold true when the following is true. K multiplied with this thing, because that's the total quantity produced as a team. So K multiplied with BV squared over theta plus BV squared divided by theta is going to be greater than just this one. This is the total quantity produced individually, which is BV squared divided by theta plus BV squared divided by theta. What do we see? We have the same factor over here. This term is common and this term is common. Now, if they cancel out, if we cancel out the terms, what are we left with? We're left with K greater than 1. In other words, indeed, if K is greater than 1, then the production as a team is greater than the production individually. In other words, we do have synergy. So if we look at the answer key over here, and they say that if K is greater than 1, we have synergy, yes, it's true, and we are done.